So this is a mass spectrometer and ionization energy pop quiz. First question one, naturally occurring bromine has two isotopes. One is 79, another one is 81. What is meant by the term isotope? So definition of isotope, basically they are the atoms of the same element with same proton number but different neutron number. So isotopes have the same protons, but they have different neutrons. The atoms of the same element with same number of protons but different number of neutrons, we call them as isotopes. The next one, complete the table to shows a number of subatomic particles in two isotopes of bromine. So for a proton number, you have to check the periodic table. When you check the periodic table, you will find that bromine proton number is 35. So this will be 35, this will be 35. Then to work out the neutron, how we work out the neutron, we take a difference between the nucleon number and the proton number. Like here, it will be 79 minus 35, which is equals to 79 minus 35, which is equals to 44. And the other one, it will be 81 minus 35, and that is equals to 46. Because these are the atoms, if we have atoms, because overall there is no net charge on the atom, so the number of the electrons and protons should be equal. So if we have 35 protons, we should have 35 electrons as well. In part 3, the mass spectrum of a sample of a bromine is obtained. Draw a dot and a cross diagram to show the bonding in molecule of bromine. Only the outer electrons should be shown. So you have to show outer electrons only. As a bromine belongs to group 7, as it belongs to group 7, it will share one electron. So each bromine will share one, that will be between them, and unshared electron will be 6. And if one of the atom you're representing by a dot, the other one should be a cross. So this is a dot and cross diagram of a bromine molecule. You can draw the circle around which shows the shells, the outer shell, like this bromine. So this is a molecule of a bromine. Describe the formation of the molecular ion of bromine in the mass spectrometer and include an equation. Like how in a mass spectrometer, what we do first is vaporization of the sample, and then we do ionization. And how ionization is done, to do ionization, like example, we have a bromine atom, because here we need a bromine molecular ion of a bromine. Like we have a bromine molecule, as they ask for molecular ion. So we target this by a fast moving electron, and this electron will knock out electron from any of the bromine. It can be multiple emissions, but we assume that only one electron is being emitted. So as one electron is being released from this structure, whenever anything loses electron, what will be the net charge? The net charge will be positive. And how many electrons will be there? There will be 2 electrons. How 2 electrons? Because the electron which we use, that is also released, and the electron which is knocked out, that one is also released. So how it can be done? It's a remove ionization, the removal of electron. So what we do, a high energy electron strike the gaseous bromine molecule, because we want to form a molecular ion. If they ask only for bromide ion, then it will be one atom turned into ion. But molecular ion, what we do, high energy electrons hit the gaseous bromine molecule and remove electron. And remember, whenever in a mass spectrometer ionization is done, it will always form a positive ion. Even though it's a metal or a non-metal, it does not make difference. The molecular ion which is formed or ion which is formed in a mass spectrometer are always the cations, because it is always by removal of electron, like forcing it to remove it. So we have a bromine in a gaseous state, we have electron. When we hit this bromine with electron, it will form a bromine molecular ion, which is also in a gaseous state, and two electrons will be there. One, the electron which we use, and another one electron which is released. So that's why there are two electrons. On the mass spectrum grid, draw the peaks of a bromine molecular ion, showing the relative peaks heights. Bromine isotopes in this sample have the same relative abundance. Means the best thing is better learn the relative abundance, especially for bromine and chlorine. But you can also work out for depend on the question as well. You can also work out example. They mentioned the two bromine, which is one is 79, another one is 81. Both are 50%. And this is a percentage relative abundance. So 50% means like 1 by 2. In terms of fraction, I can say this is 1 by 2, this is also 1 by 2. Now, what are the possible combinations I can have? We may have a bromine, both of them are 79, because in a molecule, a molecular ion of a bromine, both of them are 79. So we will get a peak at 158. Maybe one is 79 and the other one is 81. We'll get a peak at 160. Maybe first one is 81 and the second one is 79. We'll get a peak at 160. And maybe both of them are 81. So we'll get a peak at 162. These are, so means we'll get the peak at 150 and 160 will be together, like, because it does not make difference what combination, but both are 160. But how to know their heights, relative heights? So this is 1 by 2. This is also 1 by 2. So we'll get 1 by 4 of the total. This is 1 by 2. This is 1 by 2. So we'll get 1 by 4. Like this will be 1 by 4. And this is 1 by 2. 1 by 2. Multiply, we'll get 1 by 4. So what is the total of these two? The total will be half. And this is 1 by 2. And this is also 1 by 2. So it will be 1 by 4. So like at 158, we get 1 by 4. 1 by 4 in terms of percentage. Like if I have 100%, what is a 1 by 4 of 100%? That is 25. This, what is 1 by 2 of 100%? That is 50%. And what is 1 by 4 of 100%? Again, 25. So I'll get the three peaks. One will get at 58, 158. Another one we get 160, and another, the last one at 162. The peak at 150 will be 25%. So when you draw the height, that will be 25%. The peak at 160, it's a 50%. And the peak at 162 is also 25%. So these are the three peaks which we will obtain. in this mass spectrum. The ratio should be 1, 2, and 1. Even any ratio is acceptable, but the ratio, because as you can see here, the ratio of the percentage for say 158, 160, and 162, like 25, 50, and 25. So ratio is 1 to 1. So even any relative height you can draw, but the ratio should not change. The ratio should be 1, 2, and 1. Like if I make this as 40, if I make this as 40, so then this should be twice 80, and this will be 40 as well. Or if I make this as 20, if I make this as 20, the double of 20 will be 40. So this will be 40. This will be 40. And the last one will be 20. So ratio should not change. Is it clear, this one? The next one, the percentage abundance of the isotopes in a different sample of a bromine are shown. Calculate the relative molecular mass of this sample and give your answer to do decimal places. So how to work out the percentage of the isotope? Multiplied by its mass, if you want the average mass of the two isotope, plus the percentage of the isotope multiplied by its mass divided by the total sum, which will be 100. So when we divide, this will give us the average mass of these two isotopes. And we have to write the answer in two decimal places. But if you see in the question, they ask for the molecular mass. So first what we did, we work out the average mass, like relative atomic mass, because the bromine 79 is 56% and 81 is 43.62%. So first we work out the average mass of one bromine, which is 79.87. That's average mass. But the question was not about the atomic mass. The question is about the molecular mass, mass of a molecule. And a molecule of a bromine is Br2. So it will be 79.87 multiplied by 2. Like average mass of a bromine times 2, that will give us the total mass of this molecule, which is 159.74 grams per mole. So this was a question related. So it's important that you read whenever you read a question, see some of the words are in bold. So you should read them correctly, because some students simply they work out the atomic mass and they consider that as an answer. So always whenever you're reading a question, those letters, those words which are in bold, read and try to understand what they mean related to the question. So this was a pop quiz which was related to mass spectrometer and the ionization energy.